I have a QE8 SPB-MT Pyro Joule Meter probe connected to an M-Link running M-Link software on my PC. The probe is set up opposite our neodymium ELF laser, beam centered on the probe. I've connected the sync output from the laser to the external trigger input to M-Link, and I've also connected the analog output of M-Link to our scope. I'm taking advantage of an ND filter wheel to set the pulse energy level for demonstration. I'll first adjust the wavelength setting in the M-Link software, make it to 1047 nanometers to match the laser wavelength, and then I'll go up here and select auto range. I will leave the instrument set to internal trigger. The default trigger level is about 10%. I'll now go ahead and open the laser shutter, and we'll be able to measure the pulse energy of our setup. We're measuring about 46 to 47 microjoules on what looks to be 100 microjoule range. We do not have any laser attenuation at this time. One last thing to do before we move on is to engage the baseline offset. That's this feature down here. Click. Take just a few seconds. This essentially maximizes the voltage available in the A to D of the M-Link when there is a high background signal. Not so important for QE8 Pyro Joule meters, but still a good practice. Let's set the M-Link up to take a data set in the statistics mode of operation. I'll go down here and select this stats mode. I'm going to set the batch size to 300 pulses, as the laser is running at about 320 pulses per second. I'll hit start. Do that again, and you can see that we have a very stable reading, 46.8 microjoules, standard deviation less than 0.5%. And you can see from the analog output from M-Link, the voltage pulse is very stable and free of noise. We could employ our unique noise suppression software here, but it would not have much effect as the measurement is already very stable. I've moved the ND filter into place to attenuate the laser such that we're making measurements on the lowest range at about 0.23 microjoules, so 200 nanojoules. You'll notice that the analog output is not very clean. It contains a lot of high frequency noise and fluctuation. I've set the trigger level at 2%, but we're still having trouble getting a good stable reading. Let's move to the stats mode, and we'll take a data set here. We'll take a couple of them. What we're seeing is we have a mean value of about 220 nanojoules, about the min and max of 200 nanojoules and 260, RMS stability 5.2%, and problems on the rep rate, seeing a stable 320 pulses per second there. Okay, now let's select the external trigger setting and take advantage of our noise suppression feature. I'll pick 128 pulses. I'll then start the data set, take a couple data sets, and you can see now we have a very stable 0.2 microjoules or 200 nanojoule reading with RMS stability of 0.838%, and the pulse rep rate, of course, is stable at 320 pulses per second with an external trigger. One other important thing to demonstrate is the microphonic noise that a pyroelectric joule meter is susceptible to. Watch the scope as I gently tap the QE8 body, notice the spurious noise on the scope. Caution: when trying to make low-level energy measurements with a pyroelectric QE8 probe, you must consider the environment. Try to isolate the probe from things that generate mechanical vibration. If you have any questions or need assistance, please call us at 503-697-1870 or email us at info@gentecheo.com.